Okay, last night I asked you to do the third example on the multiple step kinematics problems. Okay, so in this one is an example of when one object's falling and one's moving horizontally. So in this question, it's a kitten that's falling from the branch of a tree 4 meters above the ground, and you're standing 6 meters away. How quickly must you accelerate in order to catch the kitten just before it strikes the ground? Okay, so my tree, and there's the branch, and here's the little kitty. Okay, and you're standing over here, and of course you're going to run in and you're going to do like this diving grab, so the kitty's going to be like right on the just at the ground as you're going to grab him. Okay, what are the two parts to the question? There's the kitten and there's you. What do we know about the kitten? Well, the kitten's falling, so we know the VI must be 0. And it's falling, so we know its acceleration must be 9.81 meters per second squared, as it is on everything that's falling. And it says that the branch of the tree is 4 meters above the ground, so the kitten has a distance of 4 meters down to fall. Now, how about you? Well, it says you're standing 6 meters away, so that means your VI is also 0. And you're 6 meters away, so that's your delta D. And it wants to know how quickly must you accelerate. You're looking for your A. Okay, so here are all our givens. Now the question is, I've said, like you have to divide the sections, divide the problem into 2 sections, and then the 2 sections are always connected. So how are the kitten and you connected? What variable connects them? Well, the kitten's falling and you're running in. You have to get there just as the kitten gets there. That means we don't know the time for the kitten, but whatever it is, it has to be the same for you. However long it takes the kitten to fall, that's how long you have to get there. So now if you look at your sets of givens, you'll see you only have one unknown for the kitten, which means you can solve for it. So you have a delta D, a VI, an A, and a delta T. So you can use delta D is equal to VI delta T plus 1/2 A delta T squared. The VI is 0, so this term disappears. And you're going to rearrange for the T squared. So multiply both sides by 2 and divide by A. So it becomes 2 delta D over A. So it's 2. Now for the kitten, everything's going down, so we can just call down positive. So 2 times 4 meters divided by 9.81 meters per second squared. Okay, so that's going to be 8 divided by 9.81. And you get 0.8 for t squared. You get 0.81549, etc. seconds squared. Take the square root, and you should get a time of 0.90305. I'll round there. There's more digits, but I'm rounding at that spot. So that's my time for me. So now I have my time. I have my delta D, my VI. I can find my A. What equation do we know? It's the same one. Delta D is equal to VI delta T plus 1/2 A delta T squared. Again, the VI term is 0. This time we're rearranging for A, so we have to get rid of the 1/2, so multiply by 2. And this time we have to get rid of the T squared, so we're going to divide by the T squared to be left with A. Your D is 6 meters, and my time, or your time, 0.90305 seconds. Don't forget to square it. Okay? So then punch it in your calculator, and you should get 14.715 meters per second squared. That's a pretty decent acceleration for a person. They wouldn't be able to keep it at that high very long, but to see a kitty fall out of a tree, you could probably do that. You could probably generate that much acceleration. Okay? So hopefully that one makes sense. Now let's move to this sheet, displacement, velocity, and acceleration problems. And I asked you to do 14, 16, and 17. So 14 says, a car moving with a constant acceleration. All right, so for 14. Now 14 is a little weird. So a car moving with a constant acceleration covers the distance between 2 points. So here's one point, here's the other point, okay? Distance between 2 points that are 60 meters apart. So my delta D here is 60 meters. In 6 seconds. So my delta T here is 6 seconds. And it wants to know, tells us that its speed as it passes here, VF, is 15 meters per second. And it wants to know, so what's the speed when it gets to the first point? Well, if you look at delta D and delta T, you can find your VAV, because we know V average is equal to delta D over delta T. So 60 meters over 6 seconds. So my average velocity is 10 meters per second. But it wants VI. So now you have to think about, and we've used this equation, we talked about it a little bit, used it a little bit, but average of anything is just equal to those two things added together and divided by 2. So in this, like if it was your 2 grades or whatever, so in this case, it's VI plus VF divided by 2. I know my VAV, I know my VF, I want my VI. So multiply both sides by 2. So you have 2 VAV equals VI plus VF, and now subtract the VF. So VI will equal 2 VAV minus VF. So VI will equal 2 times 10 meters per second minus 15 meters per second. So 20 minus 15, my VI should be 5 meters per second. That's for part A. Part B says, what is the acceleration? Well, now that you have your VI and you have your delta T and your VF, you can find A. A is equal to VF minus VI over delta T. So A is equal to 15 meters per second minus 5 meters per second, what we found over here, divided by 6 seconds. So 10 divided by 6, 1.6 repeating, I think. Yeah, 1.6 repeating meters per second squared. Part B. And then part C says, how far behind the first point was the car at rest, assuming it had the same acceleration? So somewhere back here, before we began to look at the question, the original VI was 0. And it's telling us the A back here is the same, so it's still 1.6 repeating meters per second squared. And this, what was our VI for the first parts of the question, becomes our VF for this section. So we have VF, VI, and A, and it wants to know how far. We're looking for delta D. Well, you have an equation that has VF, VI, A, and delta D in it. It's VF squared is equal to VI squared plus 2A delta D. So rearranging delta D should be equal to VF squared minus VI squared over 2A. And in this section, the VI is 0. So just in case I lost you, right? So the final velocity of the earlier section is the initial velocity of the later section, right? So the two sections are connected here. So delta D is equal to 10 meters per second squared, so that should be about 100, divided by 2 times 1.6 repeating meters per second squared. So delta D equals, on the top is 100, on the bottom is 3.3 repeating, so 30? You get 30 meters, maybe? Oh, I think I screwed up. 7.5, what did I do? Oh, this isn't 10, it's 5. I found 5 and I wrote down 10. Sorry about that. So this is 5. So this is 5, so it's 25 divided by that. So a quarter of this, yeah, it's 7.5. meters per second, or meters. Sorry about that. It's good. I wrote 5